Hello students, in this lecture we are going to study about haloform reaction. So what is mean by haloform? Haloform means three forms are there: methane derivative, trihalogen derivative of methane. From methane, if we replace 3 hydrogen by 3 halogen, we get its corresponding haloform. So CHCl3. So 3 hydrogens replaced by 3 chlorine. The name of this haloform is chloroform. If these 3 hydrogens are replaced by 3 iodine, then we get iodoform. And if 3 hydrogens replaced by 3 bromine, then we get bromoform. In these 3 haloform, this iodoform is the most important haloform. So we will study about the preparation of iodoform from the haloform or by the haloform reaction. So what is a haloform reaction? Let's see. When the aldehyde or ketone which contain CH3CO group, if aldehyde or ketone which contain methyl ketone group, the name of this compound is, or this group is, methyl ketone group. Methyl ketone means, here this is the methyl group CH3 and CO means ketonic group. So methyl ketone group is present in aldehyde or ketone, then this aldehyde or ketone undergo haloform reaction. So how the reaction takes place? Let's see. If we take the example of methyl ketone group containing ketone or aldehyde, suppose this is the aldehyde, acetaldehyde. So only one aldehyde is there which contains CH3CO group, like acetaldehyde. Here we take one example of aldehyde is nothing but acetaldehyde. So in acetaldehyde, CH3CO group is present. When it undergoes haloform reaction, the reaction takes place with sodium hypoiodide. So this is NaOI, sodium hypoiodide. Sodium hypoiodide. So this sodium hypoiodide is supplied by NaOH and halogen iodine, and the mixture is heated. This NaOH and iodine supply this sodium hypoiodide. Now when the reaction takes place, what happens? This CH3CO group, this CH3 group is converted into CHI3, haloform. So these 3 hydrogens are replaced by these 3 iodine and we get, so here these 3 hydrogens are replaced by the 3 iodine, we get CHI3 plus the byproduct. So this ONA group, remaining ONA group combined with this remaining part of this aldehyde CHO group, means here we get HCOONA, sodium formate is the byproduct, and one more NaOH remaining is, so here to balance the reaction, this 3 NaOI finally converted into remaining byproduct, that is twice NaOH. So we get here haloform is nothing but the iodoform. When this iodoform is formed, yellow precipitate is formed, and we can identify presence of yellow precipitate is formed, and we can identify presence of methyl ketone group in the aldehyde or ketone. So if LOPPT is formed, is nothing but the formation of iodoform in the reaction. So this is a iodoform test which is used for the preparation of iodoform from the aldehyde or ketone those contain CH3CO group. If the aldehyde or ketone contains CH3CO group, then only it is converted into, finally it is converted into yellow precipitate of the iodoform. Okay, so this is the iodoform. CHI3 means iodoform is formed from the given aldehyde or ketone which contain which group is present? CH3CO group. So this is about the preparation of iodoform from the CH3CO group containing aldehyde or ketone. If you take a second example, instead of acetaldehyde, if you take acetone, so CH3CO CH3. If you observe in this ketone there is a CH3CO group is present, means this ketone is useful for the preparation of iodoform. So if you observe this ketone, then in this ketone CH3CO group is present. When it undergoes a haloform test, means the reaction takes place with sodium hypoiodate. NaOI is nothing but sodium hypoiodate, and this sodium hypoiodate is supplied from sodium hydroxide and iodine mixture, and the mixture is heated. This NaOH plus I2 supply the sodium hypoiodate. Now what happened? This CH3 group present, which is converted into CHI3 group. So we get here main product CHI3. This is the yellow precipitate is formed, which is nothing but the iodoform. So we get yellow precipitate of iodoform plus byproduct. So what we get the byproduct? This CH3COO ONA. This ONA gets combined with the CH3CO group. So we get one more byproduct CH3CO as it is, and combined with ONA group with removal of remaining twice NaOH. So here we get the main product is nothing but iodoform. If the aldehyde or ketone contain CH3CO group, then only it is converted into iodoform, and this is the useful test for the production of iodoform from the compound those contains methyl ketone group CH3CO group. If we take one more example, now if I will give you the bond line formula of the compound, suppose I will give you this compound, which contain 4 carbon atom, and you tell me either it undergo or it shows iodoform test or not. So if you observe in this compound, this OH group attached to the carbon, which is means at the end of this, in this bond line formula, CH3 group is attached to this carbon, which is further attached to OH group, and this is a secondary alcohol. If I can convert this formula in its structural form, so this is 4 carbon containing alcohol, and in which, if you observe, this is the carbon which is attached to the OH group, and therefore this is secondary alcohol. So secondary alcohol, when undergoes oxidation, it gives its corresponding ketone. So CH3CH2 group as it is, CHOH group is converted into CO, and finally it is converted into ketone butanone, and this butanone contain CH3CO group is present. So those aldehydes or ketones which contain methyl ketone group, they show or they undergo the formation of iodoform or the haloform test. So if it further undergoes haloform reaction, means reaction with NaOH and iodine, and the mixture is heated, this CH3 group is finally converted into CHI3, and this group is finally converted into ONA, means sodium salt of carboxylic acid. So CH3 group is converted into yellow precipitate of iodoform plus remole of byproduct CH3CH2CO as it is combined with ONA. So here we get yellow precipitate of this iodoform. So if you observe this CH3 group present in this methyl ketone group finally converted into iodoform with the formation of yellow precipitate. So if the alcohol, secondary alcohol, when undergo oxidation, it gives ketone which contains CH3CO group, and this CH3 group is finally converted into CHI3. 3 hydrogens are replaced by 3 iodine, and we get the iodoform. So haloform test is only shown by the aldehyde or ketone which contains CH3CO group. If I will give you second example, if I will give you the bond line formula of alcohol like this way, OH. Now you tell me either this alcohol undergo haloform test or not. Then how to decide this alcohol either undergo haloform test or not? Then if you observe the both side of this OH group, this is the carbon which is bonded to the OH group, but it is directly bonded to the carbon which is CH2 group, and at the on other side of this OH group, other CH2 group is present. So no any CH3CO group is present when it undergoes oxidation. If it undergoes oxidation, what do we get the product? See, this is the here this 1 2 3 at this position OH group is converted into CO group, and further it is here we get this ketone. So if you observe this ketone, there is no any CH3CO group is present, and therefore this alcohol do not show haloform test. Okay, now one more limitation is there, and this is the most important thing. If carbon-carbon double bond is present in any aldehyde or ketone, means unsaturated aldehyde, ketone or alcohol. Suppose we take an example of CH3CO CH double bond CH2, and tell me either this reaction show or either this compound undergo haloform test or not. Now remember, if the compound which contain CH3CO group is present, but again there is a carbon-carbon double bond is present in the same ketone, then this compound does not undergo haloform reaction. So no haloform reaction is shown. This compound not undergoes haloform reaction. There is no formation of iodoform because this compound contain carbon-carbon double bond. Unsaturated ketone, even though it contains CH3CO group, it does not undergo haloform reaction. So these are some limitations for the haloform reaction.